NCERT Physics, Chapter 1, Point Charges on a One-Dimensional Axis. Another typical Coulomb's Law problem. However, this is interesting the way this point charges on a one-dimensional axis problem is phrased. See, the point charges have values magnitude plus 4q, minus q, and plus 4q as well. However, what is interesting to note here is they are again placed on a one dimension. That is, they are placed on a straight line again. So it's just like the previous video which we did in this channel. So there is a charge in between located at A, but right after A it's 2A, which is twice the distance, which means the distance between all those particles are still A and A. So plus 4q and minus plus 4q are the two charges that we have here. Apologies for my 4. So the question here is again simple. What is the equilibrium being present here? Now we can only say if it is equilibrium if the net force equal to 0. If the net force on an object is equal to 0, we say that an object is in stable equilibrium. So ultimately the question here is not to about directly finding equilibrium, but it is to find the net force on the charges. So if the net force on the charges, we say for that example, we can find the net force on any charge for that matter. Okay, we can pick any of the charges available to us here. So since we have three charges A, B, C, I can just find the net force on any charge. I can find the net force on A, and the net force on A will simply be f of AB, f of AB plus f of AC. So that is going to be the answer that I am in fact looking for. So it's very similar to the problem we did in the last video as well. See, just like how we have a system over here, right? The net electrostatic force that I'm going to calculate here due to the other two charges, that is going to help me decide what is going to be the net force over here. So literally I'm going to start making the calculations for f of AB. So f of AB is equal to k plus 4q into q over a. Remember, the distance between them is still a. So finally the denominator distance is still a squared. And what about the distance? What about the other two charges, right? F of AC, right? So when I calculate f of AC as well, it's also going to give me a similar equation because the charges on the ends are still the same. It is still 4q and 4q. So since the charges on the ends are the same, I'm still going to get the same answer over here by a squared. So eventually what I'm going to get is just going to be the double of the force itself, because since the values are all the same, hence the system is not in equilibrium. So I have to choose the option 3. All charges are unstable, because naturally there is a net force on the system. So if there is a net force on the system, naturally there's going to be an acceleration on the system, right? So 3 is the most logical question, while 1 and yeah, 1 like catches the label of I always have 1. There's always an idiot choice, right? So in fact 1 is the idiot choice over here, because minus q can never be in stable equilibrium, because it's always under, there is a net force due to the presence of the whole system around. So that's where you have your calculation, and you can see that the answer still remains the same, even though I left out the minus sign as well. Thank you, dear students.